looks something like this, just a single fraction equal to some other fraction, all we are going to do is cross multiply. And then continue to solve for x, just like we've been doing when trying to see if something crossed the horizontal asymptote, right? We set it equal to some value, cross multiplied, solve for x if we could, right? Okay, so in this example, that's exactly what we would do. So if I multiplied this direction, I am multiplying 5 times x minus 3. This direction, I am multiplying 7 times 2x minus 9. So when we continue to solve, all we would need to do is distribute, right? So when we distribute, we'd have 5x minus 15 equals 14x minus 63, all right? All right, so we probably would want to move all of the variables to one side, right? So I'd subtract the 5x. What is 14 minus 5x? 9x, good. And then I'd want to move that negative 63 over there with the 15, right? So I'd add 63 to negative 15. So what would that give us? 48. So we end up with 9x equals 48. So we need to divide, right? But can I simplify 48 over 9? So I would say my solution is x equals 48 over 9. Okay. Also, something that we need to check for, guys, whenever we are solving is to make sure that there are not any extraneous solutions, right? Anything that would make the function not work. All you have to do to check for that is consider what your domain would be. So what I mean by that is we know we're not allowed to have what in the bottom of a fraction? 0. Well, the only place I could plug in an x in the bottom of a fraction would be right here, right? I would not want to plug in something for x that when multiplied by 2 would give me 9, right? Because if I did that, then 9 minus 9 would give me 0, right? So 2 times what would give me 9? What is it? Okay, so 2 times, just think of it as 9 over 2, right? That would be what I don't want to plug in. Okay, so this is my solution. X cannot equal 9 over 2, right? But because there is nothing in common between these, then this solution is good. We're good with this solution. We didn't have anything overlap with any of our extraneous solutions. All right? Okay. Now, if you look at the second example, it's not quite the same, because we got a couple fractions on one side equal to a whole number, right? It doesn't necessarily matter that the far side is a whole number. What matters here is that we've got multiple terms on one or sometimes on both sides of the equation. You could potentially have multiple terms. Well, you notice that it's asking that we add here, right? Well, if I want to add fractions, what do I have to have? Common denominator. So I want this entire equation to have a common denominator. So what would we say would be the common denominator for this example? Right. So I want every single one of these to have the denominator 2 times x plus 1. Okay? So what would we multiply that first fraction by so that we get the denominator 2 times x plus 1? 2. So I'd have 3 times 2 in the top, and that 2 times x plus 1 in the bottom. Perfect. Okay? Now the next fraction, it's got the 2. What would we want to multiply that one by? Right? So 5 times x plus 1 over 2 times x plus 1. All right, and then on this other side, we have 1, which is the same as 1 over 1, right, if we wanted it to be a fraction. So what would I have to multiply this one by? Right. So I'd multiply the top by 2 times x plus 1, and I'd multiply the bottom by 2 times x plus 1. Well, multiplying it by 1 isn't really going to change anything, right? So top and bottom will just be 2 times x plus 1. Okay, now that we have the common denominator, I can ignore the denominators and just solve the numerators, okay? So now I'm only concerned with what we've got going on in the numerator. So that first fraction would be 3 times 2, which would give us, right, plus, in the second numerator, I've got 5 times x plus 1, which I could distribute, and that would give me, right, is equal to, over here we said multiplying by 1 wouldn't change it, so it's really 2 times x plus 1. And I could distribute that 2 into that parenthesis, right? So that give us 2x plus 2, right? And then I just would need to solve for x. All right, so we'd probably start with combining some like terms. Over here, I've got 6 and 5. So I should have 5x plus 11 equals 2x plus 2, right? All right, so I'd probably want to move all the x's to the same side. If I move that 2x over, I'm going to have 3x, right? And if I move the 11 over with the 2, it'll be equal to -9, right? So what do we get for x here? -3. So x equals -3. All right, now the only thing I need to do is go back and check for any extraneous solutions. Well, they all had the same denominator now, right? The only place to plug in for x would be in this parenthesis right here. Right? It's the same in all of them. What would I not want to plug in for x because it would give me 0? -1, right? So my extraneous solution in this case would be x cannot equal -1. Luckily, that's not the solution we came up with, so our solution was good. X is equal to -3. All right. Okay, let's look at example number 3. Okay, for example number 3, again, we've got several terms, so we need a common denominator, right? In order to determine what that common denominator should be, we should probably factor these denominators to see what they are. So what would n squared plus 7n plus 6 factor into? Right. So n plus 1 and n plus 6. And luckily, these two are the same in the denominator. So really, the only thing I need to do so that all of these have a common denominator is what to that first fraction? Right. I just need to multiply this one times n plus 6 in top and bottom. Right? Okay. So now that we got that common denominator, all we need to worry about is numerators, right? So here, I distribute that 4 to n plus 6, and it's going to give me 4n plus 24, minus, the next numerator was just a 1, equals the next numerator, which was just 3. All right, so combine those like terms. We're going to subtract and divide, and we get that n equals what? Right. All right, and then again, the only thing we have to check for is any extraneous solutions. So we're going to check in the bottom of these fractions, guys, what would I not want to plug into this parenthesis? Right, and what would I not want to plug into this one? All right, so our extraneous would be n cannot equal -6 or -1. Again, lucky for us, that did not interfere with the solution we came up with, so our solution is good. All right. Okay, I want you guys to flip it over on the back. Try examples 4, 5, and 6. And then we'll all share what we come up with. So not only solve, don't forget to double check and see if there are any extraneous solutions. with their solutions, but they forgot to go back and check for extraneous solutions. So do not forget to go back and check for what x cannot be.
I'm just joshing.
All right, let's check what some of us have come up with so far. So for example 4, what did we need to do first?
Multiply both sides by 2x minus 3 and 2x plus 3. Get the common denominator.
Okay, we need to get the common denominator. Okay, and you decided that was the common denominator by factoring this one, right?
Yeah.
Okay, so 2x plus 3, 2x minus 3 was a difference of squares. So you multiply the first fraction by 2x minus 3. All right. And then we multiplied the second fraction by the 2x plus 3, right? Okay. So now that we have a common denominator, I only care about the numerators, right? So here, 5 times 2x, 5 times negative 3. What's that going to give us? Good. Plus, here I need to distribute the 4, which is going to give us, nice, which equals the piece that already had the common denominator to begin with, the 14x plus 3, right? Okay, where did we go from here? Combine like terms. Okay, so 10x and 8x gives us 18x. Negative 15 and positive 12 would give us negative 3. Equals 14x plus 3. All right, so we move all the x's to the same side. We have 4x. I have to add the 3. So I end up with 4x equals 6. So we end up getting x is equal to 6 over 4, which simplifies to 3/2. Perfect. All right, so we came up with a solution, but now what do I still need to check for? Extraneous solution. So I come back to my factors, right? These pieces, these pieces, these pieces. What would I not want to plug in for x because it would give me a 0? Right. I wouldn't want to plug in a positive 3/2 here or a negative 3/2 here. So what we're saying is x cannot equal positive or negative 3/2. Well, is that a problem for us? Yeah, because this is one of those things, right? So in this case, because it's extraneous, we did not come up with any real solution. All right. Okay, let's take a look at example number 5. So again, just like last time, in order to figure out what our common denominator should be, we're going to have to do a little factoring, right? So what can I factor out of the denominator in that first fraction? A v. Yeah, so this would become v times v minus 6, right? And then this one would be the same. So these two actually already have a common denominator. It's just that last one we need to fix, right? What should we multiply that last fraction by? V minus 6. So in top and bottom, I'm going to multiply by v minus 6. All right, so now I'm only going to worry about numerators. So I've got this numerator, v squared minus 5v plus 4 equals, the next numerator was just 1, plus, this one we actually multiplied. So I am going to need to distribute, and I'll get v minus 6, right? Okay. So now we're going to need to move everything to one side of the equation. So I'd have v squared. If I move v over, I'd have negative 6v, right? And if I move this 6 over, I'd have plus 10. All right. Oh, wait, not 10. Wait, yeah, that's right. Is that a 4? Did I get that right? Yes, that's a 4. Okay. All right. Okay, and is there anything that we can do here? Oh, wait, I missed a 1, didn't I? Yes, when I move that 1 over, this becomes a 9. I apologize. So these ones, when moved over, give us that 9. Okay, so now I need to find a solution from this quadratic equation. We might come up with 2. Does this factor? Yeah, into what? Okay. So because they're the same factor, they're actually just going to give us the same solution, right? We end up getting v is equal to 3. Okay, but I need to go check. What would I not want to plug in for this v? 0. And what would we not want to plug in for this one? 6. So we also need to consider that v cannot equal 0 or 6. But lucky for us, that did not affect the solution we came up with. So v equals 3 is a real solution. All right, so this is the one I saw some of us struggling with. So let's take a look at example number 6. What's going to be our common denominator on example 6? Yes, both of these things. Yeah, so we'll have 3a, we would need to multiply it by 2a minus 1, right? All over that common denominator of 2a plus 1, 2a minus 1, minus, this next one would need to be multiplied by 2a plus 1. So all of this over that common denominator, 2a minus 1, 2a plus 1, equals 1. Well, 1 would have to be multiplied by both, right? So this one ends up as 2a plus 1 times 2a minus 1 over 2a plus 1 times 2a minus 1, right? Okay, so in the first fraction, we would need to distribute, right? What do we come up with there? All right, 6a squared minus 3a, okay? Then here I am distributing a 4, but remember guys, that is a negative 4 there, right? So that would end up being negative 8a minus 4, right? Okay. Then I would have to FOIL out that 2a plus 1, 2a minus 1. So what do we get when we multiply that together? Right, 4a squared minus 1. All right, and now that we've got those common denominators, we don't care about the denominator anymore. This is all we're worried about. So I would need to move everything to one side, right? So I subtract 4a squared from 6a squared, and I get 2a squared. I've got negative 3a and negative 8a, which would be negative 11a. Then I have this negative 4, and I'll be adding 1. So I'll have negative 3. All right. So, is there any way we can factor this? Does this factor? But does that mean that there's not solutions? No. What could we use if it doesn't factor? The quadratic formula. Right. So quick reminder, that's negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, this is a, this is b, and this is c. So we'd have negative 11, right, or just 11, plus or minus negative 11 squared minus 4 times 2 times negative 3 all over 2 times 2. All right, so negative 11 squared is going to give us 121. So I got 121 minus 4 times 2 would be 8, and 8 times negative 3. Right, and there was already a negative here, right? So two negatives are going to make it a positive 24. All over 2 times 2, which is just 4, right? Okay, and 121 plus 24 is 145. Okay, as we know, if it didn't factor, that means it's probably some sort of a decimal, right? It's not an imaginary number because we don't have a negative under there. But if it's going to be a decimal, this is just as accurate of an answer, right? Because we're not having to round. Let's just double check and make sure our extraneous solutions aren't this, which I can't imagine they would be, right? So look in these factors. What would I not want to plug in here or here? So as long as it is not positive or negative a half, we're good. Well, that's not positive or negative a half, right? So these would be our 2 solutions. We came up with 2 real solutions. All right? Okay.